In this tutorial video, I will be teaching you how to get the domain, the x-intercepts, the y-intercepts, the zeros, the vertical asymptote, the horizontal asymptote, and the whole of rational functions. Let us first define what is a rational function. A rational function is any function that can be written as the ratio. So when we say ratio, we have the numerator and denominator of two polynomial functions. Now let's have our problem number 1. Let's say we have f of x is equal to x squared minus x minus 6 all over x minus 3. We're going to find the domain, the x-intercept, y-intercept, zeros, the vertical asymptote, horizontal asymptote, and the whole. If you notice, we have guide in every item. So for the domain, so let's find first the domain. The domain is the set of all numbers except the zeros of the denominator. So for the domain, let's say A, domain, find the zeros of our denominator. So our denominator here is x minus 3. So copy x minus 3, just equate to 0. So solve for x. So we have x is equal to positive 3. So our domain is x such that x is an element of real numbers except 3. Except 3. Okay. Or simply just get the value for x to make our rational function undefined. So get our denominator, then equate to 0. Then letter B. X-intercept. Our guide, to find the x-intercept, let y be equal to 0. So f of x, that stands for our y. So we have y, f of x is our y. Then we have x squared minus x minus 6 all over x minus 3. Let y be equal to 0, so y be 0. And we have now x squared minus x minus 6 all over x minus 3. Cross multiply, so we have 0 times x minus 3, that will become 0, is equal to x squared minus x minus 6. Now let us factor x squared minus x minus 6. Okay, to get the factor, get the product of negative 6, the sum must be negative 1. So factoring general trinomial, so x and x, factors of negative 6, we have negative 3 and positive 2. Let us check. Negative 3 times positive 2, that is negative 6. Negative 3 plus 2, that is negative 1, or simply negative x here. So this function is just equal to x minus 3 times x plus 2 all over x minus 3. Okay, let us write here, go back in letter B. 0 is equal to, just copy the factored form, x minus 3 and x plus 2. Now, equate to 0. So we have x minus 3 is equal to 0 and x plus 2 is equal to 0. Solve for x. So x is equal to positive 3 and here x is equal to negative 2. So we have two x-intercepts. We have 3, 0 and negative 2, 0. But take a look in our domain that our x must not be equal to 3. So we're just going to consider negative 2, 0. So our x-intercept is negative 2, 0. Where did we get 0? That is the value of our y. So let's have a short review. Our x-intercept is a point. That means it must contain our abscissa and ordinate. So our x here is negative 2, then y 0. Now letter C, y-intercept. Y-intercept. For the y-intercept, let x be equal to 0. So we have let x be equal to 0. So y is equal to, just substitute our x to 0. So we have 0 squared minus 0. Change x to 0. Minus 6 all over 0 minus 3. Now we have 0 squared, that is 0 minus 0, that is 0 minus 6, so negative 6 all over 0 minus 3, negative 3. Negative 6 divided by negative 3, that is positive 2. So our y-intercept is, our x is 0, so we have 0, positive 2. Okay. This will be our x-intercept. Okay, or y is equal to 2. Next, letter D. Now let's have the zeros of our rational function. Zeros. In our guide, this is the same as our x-intercept. So letter B, x-intercept, we have our solution here. And we're going to find the value for our x. So x here is equal to negative 2 and positive 3. But take a look in our domain. Our restricted value for x is 3. So x is a restricted value for our zeros. X is equal to negative 2. Discuss here because this is a crucial part. Let's have our first condition. D here stands for the degree. If the degree of the numerator, n stands for the numerator, if the degree of the numerator is less than the degree of the denominator, our y is equal to 0. If the degree of the numerator is equal to the degree of the denominator, we're going to use a over b, where a is our leading coefficient in the numerator and b is the leading coefficient in the denominator. And if the degree of the numerator is greater than the degree of the denominator, we don't have a horizontal asymptote. Now, studying our given, the degree of our numerator is greater than the denominator. In our numerator, we have here our quadratic, so our degree in the numerator is 2. And in our denominator, that is a linear function, so 1. So, the degree of the numerator is greater than the degree of our denominator. So, horizontal asymptote, in this case, we don't have. So, none. There is no horizontal asymptote. Now, let's have G, the whole. Okay. Whole is also known as the removable discontinuities. So these are the values or the inputs that causes our numerator and denominator be 0. So in this case, notice that we have a common factor x minus 3 in our numerator and in the denominator. So these are the discontinuity of our function. So get the common factor for the whole. We have x minus 3 is equal to 0. That is a common factor. So find the value for x. So x is equal to 3. Now we have our abscissa or our x. To find our y, get the remaining factor in our numerator, which is x plus 2. So x plus 2. Now, substitute the value of our x, which is 3. So we have 3 plus 2. Now we have 3 plus 2, we have 5. Now the coordinate of our whole is x is 3. Then this will be the value of our y. 3, 5. That would be the discontinuities of our rational function. 3, 5. This is the whole. Again, if we have a common factor in the numerator and denominator, get the common factor, then equate to 0, then solve for x. And after that, substitute to get our ordinate. Okay? That is on how to find the domain, x-intercept, y-intercept, the zeros, vertical asymptote, horizontal asymptote, and whole. Let's have our second example. Now let's have our second example. F of x is equal to 1 over x minus 1. Let us find the domain. So letter A, domain. So get the denominator, x minus 1, equate to 0. So x is equal to 1. So our domain is x such that x is an element of real numbers except positive 1. B, the x-intercept. For the x-intercept, let y be equal to 0. So x-intercept. So y is equal to 1 over x minus 1. Again, f of x is the same as our y. So let y be equal to 0. So we have 0 is equal to 1 over x minus 1. Cross multiply. So we have 0 is equal to 1. Notice that we don't have a value for x because 0 times x minus 1 is 0. So that means we don't have no x-intercept. Or simply none. For the x-intercept, none. Letter C, y-intercept. For the y-intercept, let x be equal to 0. So we have y is equal to 1 minus x minus 1. Let x be 0, so we have y is equal to 1 over 0 minus 1. And that is 1 over negative 1. Therefore, y is equal to negative 1. So our y-intercept is 0, negative 1. That is our y-intercept. And for the zeros, letter D, zeros, the same as the x-intercept. So we don't have x-intercept. So zeros, none. And for the vertical asymptote, letter E, these are the restricted values for x, vertical asymptote. According to our domain, x such that x is an element of real numbers except 1. So, vertical asymptote, x is equal to 1. Letter F, horizontal asymptote. 1 over x minus 1. So, study our condition. if the degree of the numerator is less than the degree of the denominator, our horizontal asymptote is y is equal to 0. So, we have here a degree of 1 in our denominator. That means the degree of the denominator is greater than the degree of the numerator. So, we have our first condition, y is equal to 0. And lastly, to find the whole, we don't have a common factor both in numerator and denominator. So, for the whole, none. Example number 3. f of x is equal to x squared minus 4 all over x squared minus 9. Okay, let us find first the factored form of our given. In our numerator, that is x plus 2, x minus 2. And in our denominator, we have x plus 3 and x minus 3, different of 2 squares. Now, get the domain. Our denominator is x squared minus 9, that is the same as quantity x plus 3 times x minus 3. So that is x plus 3 and x minus 3 equate to 0. Now solve for x. We have x plus 3 is equal to 0 and x minus 3 is equal to 0. So we have x is equal to negative 3 and x is equal to positive 3. For our domain, x such that x is an element of real numbers except positive, negative 3. Okay. And for the x-intercept, letter B, let y be equal to 0. So f of x, that stands for our y, so 0 is equal to x squared minus 4 all over x squared minus 9. Cross multiply, we have 0 is equal to x squared minus 4. Get the factored form of x squared minus 9, so that is 0 is equal to x squared minus 4. Factors are x plus 2, x minus 2. Now equate to 0. So x plus 2 is equal to 0. The other one, x minus 2 is equal to 0. So our x-intercept, we have two values. We have negative 2 and positive 2. Okay. That is our x-intercept. And letter C, y-intercept. Okay. Letter C, y-intercept, let x be equal to 0. So in this case, y is equal to, let x be 0. So 0 squared minus 4 all over 0 squared minus 9. So that is negative 4 all over negative 9. Negative divided by negative, that is 4 over 9. So y is equal to 4 over 9. So we can write this as 0, 4 over 9, so that you can easily plot the points. And for this one, we have x is negative 2, 0, and 2, 0. Okay. Now, get the zeros. Letter D. Zeros. For the zeros, same as the x-intercept. So letter B, x-intercept. So our zeros, x is equal to positive, negative 2. Okay. Next, letter E, vertical asymptote. Okay. For the vertical asymptote, according to our domain, our restricted values are positive and negative 3. So for the vertical asymptote, we have x is equal to positive 3 and x is equal to negative 3. Those are the vertical asymptote. And letter F, horizontal. So examine our condition. Condition 1, if the degree of the numerator is less than the degree of the denominator, that is y is equal to 0. So study our given, we have the same degree. So our degree of the numerator is equal to the degree of the denominator. So we're going to use y is equal to a over b, wherein a is the leading coefficient in the numerator. In this case, we have 1 over b is the leading coefficient in the denominator. We have also 1. So 1 divided by 1, that is 1. So our horizontal asymptote is y is equal to 1. And our whole, as you can see in our factored form, we don't have a common factor, so we don't have 9. I hope you understand the rational function and how to get the domain, x-intercept, y-intercept, the zeros, vertical asymptote, horizontal, and the whole. Thank you for watching Senior Pablo TV.